Hey everyone, thanks for joining. Today we are going to learn how to look at malware, specifically a well-known malware called WannaCry ransomware. Don't worry if you are new, we'll keep it simple. We'll look at how to study malware in three ways: static analysis without running it, dynamic analysis running it safely, and behavior analysis what it does overall. WannaCry is a great example because it's easy to understand and show us how real world attack happens. Let's get started with static analysis first, but before that you need to download sample and set up your lab properly. I hope you know how to set up a malware analysis lab in a virtual environment. So I'm going to start from downloading the sample and analyzing the sample directly. Now go to any.run. So any.run provides sandbox environment where you can detonate a malware and you can see the behavior, network logs, process logs, every single thing over here as well for behavior analysis. So most of the things are there, but I'll tell you how we are going to do in our environment only. But first we need to download a sample, so we can download these samples from any.run. It's a great platform where you will find numerous great malware ransomware which you can download and you can analyze. You just type in WannaCry ransomware any.run. Just click on that first link. Okay, clicked on first link and now you can see this is how yeah, this is the hash. Okay, so just click on this hash and now you can see this is the link. I provide you this link in the description as well, so you can analyze this sample as it is. So you can see here a number of options. You can see process, and but I want to download sample, so here you need to sign up and sign in if you haven't. So verify you are a human, and the sample will be downloaded. The password is infected, and also this is saved in the download folder. You can click on this and you can see here it's in download folder. And importantly, yeah, you need to create snapshot once you downloaded your before downloading your sample. Okay, I already have created malware clean lab. So whenever you miss some steps, or you are able to trigger this ransomware in your virtual environment, then definitely this can be contained by just reversing all of this. Yeah, so now let's move it to the desktop. After moving it to desktop, you you need to extract it. Let me try default extractor. Okay, it's not working. Just close it out. You can right click and check some other decompressors. Extract to, yeah. You can type password here, infected, right? Go here, yeah, security. Now you have to change also the security, firewall settings. So there are different protection mechanism. If you want to analyze in a contained environment, you need to shut down. Okay, so your threat won't be deleted. Yes, off, off, temporal protection off, everything is off. Just close it out. Okay, now I'll extract it again. affected. This is the password, and you can rename it with WannaCry.exe. Yeah. Now, once you done that, so first of all we need to download PE Studio. There are a lot of tools like this, so PE Studio I like this one personally because it gives you enhanced analysis of static analysis for that file. You can go and check so many things from there, and there are shortcuts directly, to navigate to web. So there is CFF Explorer also. uh, okay, in late 20s we were using that early, but it won't fix your import address table and export IAT tables while dumping processes from memory. So to and you can't change the relative virtual addresses and raw addresses from there to fix your PE file. So it becomes an issue without doing that. So uh, so PE Bear is the tool to do that. But yeah, here I downloaded this PE Studio. Now I have to you know see this application. I'll pin it to my taskbar so it's accessible to me every time. Okay, so yeah, you can just minimize it. If you want to run, it will say this run anyway. Now what we are going to do, we're gonna load our ransomware file inside this one, PE Studio. Open it, desktop, create it. Yeah. So now you can see here a virtual virus total detections for this files, DOS headers. That information is also there, and then stub information is also present over here. There's so many sections, number of sections. You can see virtual size, how many bytes it is, virtual addresses, raw addresses, and ratio. So entropy is 6.64 for section 0, but there is some value I can see. There is a 8 entropy. Libraries count, you can see libraries used, DLLs. Yeah, now we are into imports. You can see these imports, right? So these imports give you an idea how analysis is working. So first of all we have create file A. So I'll write create file A, and you have to check Microsoft documentation every single time, whenever you stumble upon these APIs. So yeah, you can read it over here what it does. File A. So create file A, it's a Windows system function used by program to open or create files. It's a part of kernel 32.dll. Here A stands for NC unique, and as suppose as like create file W is also used, which is for Unicode wide characters. Okay, so it's important because this API used during this kind of operation like encrypting file, dropping malicious files, or creating files, modifying files. Not only malicious, if you are dropping normal file or downloading any file. So decrypting files, So or decompression. Now look at enter critical section. So this is also a Windows API used for thread synchronization. Think of it as like a lock. It makes sure only one thread of a program can access a specific section of a code at a time. Okay, this prevent race conditions where multiple threads to try to read and write at the same time of data at the same time, which can also lead to crashes. So in simple term, you can imagine like you and your friends are writing in the same notebook. To avoid messing up each other's work, you both have to agree one of you can write at a time. So under critical section is how one thread says I'm using the notebook now, and it won't let others it until it's done. So why malware authors need it? They want to stay organized, avoid crashing, and manage access to shared resources like memory or files. Now let's see get temp path w. It's also it's also a Windows API function that returns the path of temporary folder used it by Windows. Okay, here W stands for wide, meaning like the same with Unicode wide character strings. mm, we have discussed previously. In simple things, think of get temp path w as a way for programs to ask Windows, hey, where is the folder where I can safely drop some temporary files. So this gives you permission for that. So why malware uses it? So it can drop or unpack files, hide malicious payload, and avoid permission issues. So they can have stealthy stay since rarely check in in their in the temp folder. So now next API we have to look for size of resource. Okay, so this is related to resource section. So size of resource, what it does is basically resource embedded in an executable file like exe or dll. You can find it on in resource section. This function works after the resource has been located using functions like find resource and load resource we already have seen. Think of an executable file as suitcase. So it can carry hidden file inside it like images, icon, language, or malicious payload or shell code. Size of resource is asking like how big is the hidden item inside the suitcase. Okay, so yeah, in normal language you can say like that. Okay, why malware is using it? Because it stores malicious code as or file as a resource, or use size of resource to know how much memory to allocate, extracting or unpacking the data using some functions called virtual allocation and all. Now let's see what open mutex do is it to open existing mutex. It means like mutual exclusion object. A mutex is like a system wide lock used to control access or to signal if something is already running. In simpler language I can relate, like think of more mutex like a sign on a bathroom door. Okay, occupied, someone is already inside. If malware uses open mutex, it's usually checking if an instance of itself is running. If the mutex already exists, the malware might quit, skip infection, log different behavior. Then why WannaCry wanted to use to prevent duplicates, avoid detections, and it wanted to have proper communication. So we can see there are a lot of APIs over here: rand, string length, wscat, wsc length. So there are so many: file operation, registry, modification events, load library, get computer name. So all these APIs are there, and you can see information about these inside msdn, and you can also go ahead and check exports. Okay, after that, and thread local storage, no data is there. Now you can also see strings. Okay, there are a lot of strings. I think it will take some time to load. You have to wait. Okay, so in strings also sometimes there are some fragment present where from where you can say okay, it's a malware file. Some strings are there, WannaCry is written. but those are not a concrete option to get a generic coverage for those things. So we need to dig deeper, because there are first stage payload, second stage payload, third stage payload. So we have to extract all of them to provide enhanced coverage for that per particular a particular file, so for analysis. So if you see here, let's uh, see our sample. And now what we will do is to go to our, is it first, this is the manifest data. And after that I'll open resource hacker. Okay, we found like, okay, some resource hacker or related APIs are being used over here. APIs like, load resource, lock resource, find resource. So uh, we need to see what's in the resource section. So resource hacker give us very good information about the manifest version, and sometimes the GUI of the application, icons and all. And we can see there is a data, a lot of data in Shia. Okay, so we can see in the file header there is PK written. Actually this signifies it's a compressed file, but I'll tell you how you can give particular verdict for that. So for this we have to check for file headers. You will find it in okay, Wikipedia as well. You can bring it and see list of file signature. Yeah, click on it from Wikipedia. Just enter press Control plus F and check for 54B. 4B. Yeah. So now I can see zip apkaar. Oh, I lost again. Sorry. Yeah. Yep. Yeah, now yeah, that's it. So you can see zip AAR, APK file, docx, all xlsx. So all of them are using this PK as a file header. So and they also contain some more data. So yeah, what we can do now, we can go ahead and uh, you know check for more, more you know evidence for this. Okay, what we have to analyze for. So now you can drop this. So we will look at the resource section while doing dynamic analysis and see whether, yeah, that's the one. So that's how we'll find out, like that's the one which is loaded into the memory from the resource section or not during dynamic analysis. But first we need to check analysis in Detect It Easy for the entropy. Entropy gives you a very good idea, like which section is encrypted and which is not. So if the entropy of a file is above 6, is it means like the file is packed. And if it's below 6, okay, it's not packed. So we can see there are several section over here, and are packed. And we can see there is a RSRC section which is like 7.9. So it is the highest entropy level. Okay, so it means like, okay, it's the highest level of packing we can see over in this region, memory region. And we and most of the ransomware malwares reside inside this. And this is the manifest again. And you can see resources, imports, info. Okay, these are the APIs. Okay, same thing. And you can see the rich signatures, those kind of thing. Okay, directory entries, optional header, file header, image anti header, dos stub, and File detectors. So yeah, it will detect file by running Yara rules. You can see the Yara rules. Okay, there are some Yara rules regarding cryptox and cryptographies, and yeah, this is it. Then you can go to hex code. You can see 45A, the MZ header marks the Zabrowski PE file, and yeah, this is the opcode assembly. Okay, this is the extractor. You can also extract, uh, information from here. Offset, address, size type. Let's close this one. Now we have to move further and see what tools we're gonna use for dynamic analysis. First of all, we'll start process explorer. So you can download these tools from, from sysinternals windows. Okay, this suite provide a lot of tools to test Windows internals. So Mark Rashinovich was the one who created this suite during in at I think 1990s 1995, I guess. So that from that time, these upgrades are going on, but yeah, they contain super important tools to analyze behavior, malware, and debug softwares, all those things. Okay, so if you are doing malware analysis, so you have to follow that path. So I can see there are some unwanted process. Let me kill them all. Okay, I'll kill them. Yeah, it's fine now. Okay, so now this is will help you to see all the processes which are process event which are going to which are happening in your system. Okay, either related to registry, or process pond, or process tree, what's happening in your stack or network. All that information will be here in process monitor. So while analyzing it, you can't open it for so long because it is backed by your virtual memory, and if you have less virtual memory, then it will be problem for you to analyze further, uh, more than 2-3 minutes, because there are millions of log which are generated in couple of seconds as well sometime. So we need to be very particular, so we will apply filter for process name. Okay, so you can apply filter for so many things, but process name will be there. Our process name is WannaCry, and we'll copy it, we'll paste it over here, wannacry.exe. Add, and click on OK. So yeah, it's done. Now you can play it. So whenever what WannaCry events start happening, it will try to capture it. But I'll this is basically to check the behavior of the of the process, what is happening. Okay, but I'm going to make it very limited. Not I'm gonna I'm not gonna explain like in depth, because I'll be more focused on dynamic analysis and reversing rather than this. So I'll tell you behave in behavior what how we see those things. Okay, just a glimpse of it, because it will make a system slower. Okay, so I have to turn it off after or turn it off or pause after some time. So we can see here, we will open x32 dbg. You can download a snapshot tools from internet. For this is for debugging exe files. So you can see the architecture is i86 i386, and model is 32 bit. So we have to launch our snapshot tool in 32 bits. So open it. Now load this file inside your debugger, drop it down. Okay, so this is it. Yeah. Yep, let me just arrange these things properly. Okay, these windows. Okay, now run it. So first of all, I'll tell you. Okay, so this was the system breakpoint when the process is not loaded inside the memory. Before that, it will hit one breakpoint, and then it looks for the TLS, okay, thread local storage. There will be breakpoint on that. Then it will go to, the original entry point. Yeah, we'll put breakpoint over there as well. So, and address and entry point as well. So you can also see SEH, okay, structured exceptional handling. So, and you can also see these DLLs which are being loaded by WannaCry, and I can see these APIs. So now I have to put breakpoint on each of everyone that we discussed previously. So what I think is important after seeing this, because yeah, you need to write in command bp and create service a, enter breakpoint is there. So we use breakpoint to stop that execution in in that particular interval of time. So then we will put breakpoint on the start service a. We want to see like what service is it starting, and seeing registry create event, registry value event, registry value event, and there we'll write bp reg create key. Okay, we will check which registry are being created. Okay, and I'll tell you in ProcMon where that event is happening. Okay, after that I'll try to stop this ProcMon to save my virtual memory and to continue with the analysis before it dies. And then you can see get file attribute, create file a. Yeah, create file a looks very interesting. You can put breakpoint over there as well, breakpoint, and then read file, write file. Yeah, write file could be a good breakpoint position. Write file, press enter. Next you can see get temp path w. You can write it over here. So I'll put breakpoint over here. Now get uh, mm, size of resource. Yes, size of resource we were looking at. We'll put size of resource breakpoint over there as well. Then we have to look for lock resource function. Maybe lock resource and press enter. and then after that load resource. Then we have sleep function, open mutex, virtual alloc. So yeah, let's put here as well. When we see there's a mutual exclusion. Okay, yes, and then we'll put virtual alloc. This is for allocating virtual memory during execution to unpack things first inside the memory, then writing on the disk. Mhm. There are a lot of APIs, get username, that current directory. You can see all of these APIs as well. Okay, now heap alloc. Okay, yeah, it means like, okay, virtual allocation is not working. Then sometimes the attacker, what they do, they check with the alternative function heap allocation. It allocates heap inside the memory dynamically, and you can perform the same action as virtual alloc. Yeah, so this is an alternative for that. So yep, and we can see create directory, get computer name, local global tree, get exit to code process, find resource, and there are some C functions as well. So basically we know, right, okay, what compiler they have used. You can see it's a C++ from because yeah, MSVCRT. Okay, refers to that only. These are the breakpoints that we are going to use during our analysis. Now what we're gonna do, okay, let me tell you our breakpoints. Where were they? System default breakpoint, entry point, and system TLS callbacks. Okay, yeah. Now first we had a system, we already hit the system breakpoint, then some callbacks, then there is a huge role played by process environment block and thread environment block over here also. Okay, but I'll tell you after. If you go deeper, you will come to know why they are really important part of the analysis, because there is ASLR, and attacker want to bypass it. Okay, so that time it plays a vital role to have a offset point in thread environment block. So yeah, you can see all the processes over here. There is till now this activity has been done already from the WannaCry. In ProcMon we can see. Now if you press step over, okay, you will get to know, okay, there are arguments which are being pushed. Okay, now we'll say, okay, run. First we hit our first breakpoint, reg create w, so it will create a registry key. Okay, so where we can see here, push base pointer is there, test ECX. This is a bitwise operation which is being performed over there. And then there is a conditional jump if equals je belongs to that. And attacker usually do that to jump to their shell codes most of the time. So we will skip, and then there is a XOR happening, then comparison, then it's pushing some values to the registry, and then you can see now it's calling the registry. So all these values are being pushed. If you go and look into process monitor also, we can see there is an activity going on, registry create key. And if we see, okay, result success denied, but still we gonna see whether there is a registry or not. Okay, WannaCry cryptor, WannaCryptor. Okay, so what we'll go to run, and in there we'll write rig date. Okay, rig date. After that rig date, you just press yes to user authentication control, and then yeah, this is HKLM, means a hotkey local machine, so you can just click on it, HKLM, and then go to software, and here you can go ahead and see whether this entry is created or not. But it's saying there is another folder, wow 64 node, and I'm not seeing any of entries are being made or here. So yeah, it's absolutely correct information, access denied. And now we are seeing these things, so it's not working on. And these are the policies, registry applications, Microsoft, you see, and they contain a lot of information. Okay, basically this is used for the persistence purpose. Okay, so now what we are gonna do is continue our analysis. Now we will just step over the instruction, return, again comparison, conditional jump, and again conditional jump, load effective, LEA means load effective address, comparison, push EAX. Now we can see there is some other again registry key is being called, and we are pushing some value inside the registry key, and now some logs are updated in process monitor as well. So we can see there is a successful entry of WannaCryptor in uh, a hotkey current user entry. So what we're gonna do, we're gonna go in our registry setting, and then this is local user, so we need to uncollapse and collapse the current user, and then go to software, and you can see WannaCryptor is there, right? So this entry has been created. So I think I can show you for ProcMon monitoring. I think this is sufficient, and you can see like every single process or and every single thread which is is executed, and how memory tree is memory tree has been executed. So, and you can also do some options like path highlighting. Okay, those kind of stuff you can do. So I'm gonna pause this after some time, because I think you get the idea how you do the behavior analysis using process monitor. So, and you have process explorer as well, so if process is suspended or something other than that is going on, you can see it over there with the process. But yeah, now we can see there's a it's successful registry tree, and there is a set value WD is being created. Okay, so now we can see as you if you remember, there was a shia, right, XIA. So this XIA was found in the resource section, which was heavily packed, and now we are seeing there is WN cry at the rate 202017, something like 20L7. Okay, that is there. This is interesting string, and we can see we hit our next breakpoint. Load resource means like, okay, it's taking from that resource section and it's loading inside the memory. So now I think if we remember properly, okay, we can see what kind of data has been pushed into memory dump, okay, for selected address, and we can also see the memory map, okay, where it is mapping, okay, and okay, so this is called from this is API from kernel base.dll. So now once it is called, it will load the resource in a particular location. Okay, whatever it is provided, it could be a temp path. We also saw the temp path in the beginning, but let it be. You can just press F8, and yeah. So if you see here, lock resource is there. Okay, so there are so many things which is going to affect our resource section over here. So I'm thinking to just, let's see what that file is. Okay, what that file contains, right? If you go and see that, you maybe you will find some interesting information. Okay, but most of the time, if entropy level is 8 or 7.9, means like it's encrypted with the password. I guess this is the password. So what we're gonna take this password and copy it. Selection. Okay, we will go to this one. Okay, notepad, and paste it over there. Where is our notepad? Yes, this is it. We open it. And we can see some previous is, now we copied that value, we can paste it over here, change it. Now open resource hacker, and paste it over here. So this is it. This is the complete file. So you are again seeing pk as this was our zip. So what we gonna do, we're gonna save it. Okay, and save it as WannaCry.exe. Should be in bin format. Maybe, let me try. Dot zip. I'll save it. We'll minimize it and go to the previous menu. Okay, I think it's hanging because of our uh, ProcMon, which is running on. But yeah, but let me save this. Yeah, bin resource. Okay, yeah, got it. Save it as zip, minimize it, rename. Let's rename this one. If you do not have file extension, you can just go to view, and from there you will find like, okay, C extension. But here we'll, I already have these settings, no problem. Yes, click on yes. Right click on the file. Okay, so now it's time to pause this. I don't think our operations will be happening on time if process monitor is still going on. here you can drop that password and paste it, click on OK. Yeah, you can see Shia 2058 something decompressed in this folder. So we will go inside this and yeah, I'll pause this capturing. Okay, now only that way I think it will be faster. Now you can see message, task DL, task E, there is some B dot WannaCry, WannaCry. Okay, it's 1 MB. Okay, these are the messages in, I think, ransomware message in all other languages: Dutch, Chinese, French, German, Lithuanian, Japanese. Okay, this is in RTF format. So if it's in RTF format, you can use rich text, editor or opener to see what's written in this file. So for the time being, I think we do not have WordPad or any of the word tool, so we'll leave it. So we can see there are some more file, uh, for some more DLLs also, and uh, and also there are some of B1 some different format is there. You need to see like what it is actually. Okay, it do not contain anything. There is a 2 MB file again. Okay, I can see this is also a pack file. What I can do, I can just right click and okay, so I think 7-zip is a very good option if you are extracting these files. Go to 7-zip, extract 2s, open this folder. Now inside this folder, we can see data and tor. Okay, this is this yeah, here the only files which won't be encrypted are these files. From this tor browser only you will be connected to the ransomware or ransomware author to to chat and to decrypt those files, those kind of things. So this will be there all the time, inside, embedded inside these ransomware files, or there could be IRC chat, and there is a task DL. So we can see, we can analyze these files as well. Okay, but right now we are getting an idea like how you can analyze a basic ransomware. So if you are diving in deep into it, you have to analyze each and every single file whatever you are seeing. But definitely we're gonna check some upper layer, some static analysis we can do. For now we are dropping it in PE Studio. Yeah, so let's load it to need to reopen this. mm, Task DLL, just drop it over there. Now again, for some analysis we can do quickly, like okay, imports are there, section counter 4, libraries 3 used. Okay, let's see what kind of file it is. Linker, it's using 6.0. Okay, these are the APIs. Get temp path, again find, next, get logical drive. Okay, get startup info. So it want to create persistence in the startup as well, that kind of information which is there. Now you can see all those crazy stuff. And now let's get back to our debugger. I can see I'm on size of resource. And yep. And I've seen some interesting fragment like SQL, SQL file. It was. Yep. Now again, size of resource, again create file. So there are more in depth into it. Maybe there are some exe, and inside those exes, again there is some resource, and doing that stuff. But here right now, what I can see, it's dropping, it's decompressing all those files, right? That from the main XIA file. So yeah. Okay. So yeah, it will repeat this process until unless this process is over. So here is the decryption loop, you can see, but this decryption loop looks pretty mm, you know generic, but yeah, this is how the decompression of uh, zip file happens. So sometimes they support LZMA algorithm. I hope you are familiar with that. Or could be different if the it depends upon the file type. So so what I'm gonna tell you is, yep, so zip is a, like, support your lampel zip compression algorithm, okay, which is also known as LZ77. And it identifies repeating sequence of bytes and then uses a directory of the sequences. Mostly you will see, it is also combined with the Huffman coding. So yep, this is how it is built. But now we can see repetitive actions again. I want to see something interesting, so I'm inside the zip file. I'm looking into this zip file, and now let's see. You can see it's again doing write file operation. What we're gonna do here now is to just run the execution plenty of time, okay, hitting the same breakpoint again and again. And you can see here what is happening. Same operation, write file operation, because it's dropping those files from that compressed folder. So if we go to process explorer and go to properties, so here we can also see some interesting stuff like process graph and strings. And if we see here, yeah, you can see how WannaCryptor software, and you can see plenty of file formats are there: .key, .sql3, xlsx, doc, png, JPEG, tar, RTF, so many. Okay, so what it's gonna do, I know, like, okay, now it's gonna look for these file formats in from the logical drives, and then try to parse those, add some bytes into those files, and uh, and repeatedly it will do that. So you can see what's happening inside the memory over here, right? So you can also see the name of the exes, and the manifest of the PE file. Okay, so manifest sometimes used by attackers to sideload some DLL, and yeah, to, yeah, for evasion purpose. It's a different technique and reversing stuff, but I'll tell you. Here, yeah, I can see public key token, but it's in manifest, so it will not carry much weight for us for the analysis. Now Press. Let's cancel this one. Anything important over here? All right. Not for now, but yeah, process explorer give you a lot of options to freeze the process, spawn process if you are going for process following, how it's working, and process injections. Okay, so this is the awesome tool where you can do the deep analysis of that memory, uh, of that memory dumps. So memory dump also contains a lot of information. So if you go to advanced Athena, like you know kind of stuff, okay, mythic agents, so yeah, they are heavily encoded and yeah, decrypted in here only. So let's see, okay, what file it's dropping. We'll go to its folder. Okay, these three files are being dropped, we can see here. Okay. Right now it's still writing. Let's run again. Same stuff which is happening. Okay, in the same folder it's dropping. Next. Next. Here you can see in accumulator register EAX, there's so many files. Okay, J, Russian, Spanish, Swedish. Okay, T taskdeal.exe, and now you can see. Okay, so if we click on ex and go to its term, we can clearly see the PE file which is being written inside that folder directory. If you want to see, so virtual allocation, what it does is create some free space inside the memory, and attacker usually use this to place their shell code into virtually allocated memory. But this is if if you are loading a library function also, so sometimes you need a virtual space for application generic softwares as well. So yeah, it creates some map inside that, and then injects that inside that memory to run dynamically those modules. So, and here we can see it, it's going to inject this stuff inside the virtual allocation. We can see clearly the PE headers as well. Okay, and ADI, which is your destination index register. Okay, so you can see here, you can follow this or follow it in you know CPU disassembler. And here we are again seeing the same stuff. So yeah, we have to see what it is, what it is doing, you know deeply. Okay, so yeah, that's my purpose over here, like, okay, to tell you the methodology, okay, how we are doing it. So but it goes beyond these things. Okay, on thread level, but for starting, you can go ahead analyzing analyze samples like this only. Okay, you'll learn a lot if you follow this pathway. So we are checking return. Okay, because if you want to see what is returned in this memory, okay, you will see and follow the selected address in dump. So this data is written inside your virtual allocated memory. Okay, so this is how you will know. Okay, 00C. Okay, so now okay, now it's trying to open the mutex. It's mutual exclusion. We already have discussed what is mutual exclusion. Okay, so now yep. So if I want to tell you again this thing, the same thing, I want to tell you if some place is already occupied, okay, and mm, but you want to solve that problem, right? So if a malware or this, this is using, okay, open mutex because it's checking if instance of itself is running. Yeah, okay, so if it's already exists, so quit, skip, or mm, log different behaviors, okay. But yeah, now I can see some interesting file.pky file, okay. Now I'll go here and I'll see. So for to make your life easier in x64, you can also write the plugins, you can code those plugins and whatever you want, wherever. Okay, so you want to detect a decryption loop, or XOR, you can create those kind of APIs and run. While running dynamic analysis, it will automatically place breakpoints in those regions. So I can see this data is there in .pky file. mm, okay, so it's been dropped, okay. Now stx bitwise operation is going on. Then create file again, and I can see ex value is 1 only. There is nothing in accumulator. And cpg gen key. Okay, what is this cpg gen key? So let's see the documentation again. So you will stumble upon so many things, okay. So you need to follow this documentation, okay, because if you are interacting with kernel, okay, so you have to know what is going on behind the scene, okay. So yeah, you can clearly see it generates a random cryptographic session key or a public private key pair. A handle key or key pair is returned in ph key, okay. So yeah, it's basically a crypto API function that requires key handle. And you can see this is the syntax. It needs crypt file key, and there will be d word, which contains the flag, and after that there is an id, okay. So all the parameters which are here are explained after that. HPROV is like a handle to cryptographic service provider, CSP, okay. And this is the thing, okay. So now we know. Let's go ahead and see what's in the temp file as well. Until unless I want to see what's dropping inside the they are dropping inside the temp file. But in previous in this directory also, file directory, you can see so many files are being dropped now. I can see some script file, bat file, you know all of them are there, okay. Encryption key, public key, resource. If you want to check, you can see in text editor to see what do they have, okay. So please read this text, okay. So just uh, double click this and you will see the message, okay. What's this, okay. So if you go ahead and you can check this. So I think my system sometime freezing. I think it's because of process monitor. I have to, and process explorer, I have to get rid of these processes because they are actually there to learn the behavior, okay, most of the time, and which is very essential part of dynamic analysis as well. But for now, for learning sake, what I'll do, I'll try to pause it, okay, and we'll continue our analysis again, okay. I'm not able to click anything now. Yeah, it's closed. Okay, I want to open. Please read me. Don't mind, I'm closing this as well. Minimize this. Okay. Yeah, so open notepad, new notepad, and open file. Okay, let's directly drop it here. Yeah, this is the text over here. Important files are encrypted. It seems you will not be able to access them anymore. Blah blah blah. This is the Bitcoin address. Send some money. Okay, to get the decryption key. Okay, so okay, so we are not gonna give. Okay, never entertain these guys to give money. Yeah, you just yeah, you just have to follow proper procedure. Okay, proper backups. Okay, so that situation won't arise. Sometimes you don't have any backups, they always delete the shadow copy, and lot of things happen. Okay. And you need that time. Okay, those files as well. Okay, which are really important to run your organization. So sometimes they end up giving, but some I have seen like they entertain these guys. So here if we look at VBS script, we can see shell has been called. Okay, what this shell will do, it will you know create some lnk file, but this is inside the command. Okay, target is this OneDrive desktop. Okay, there is something happening in the temp directory as well. So we have to look for that. Just step over, 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 step over. We are inside the kernel. Now create file event A again. Sorry, click the wrong thing. Next, next, next. Oh, okay. I can see there is a temp file and wcs length. Okay, edi. So this function will be called, and it will be moved to edi. But still we need to see if they have dropped any file in here. Okay. Dot says looks like the drop. Dot says no. Okay. Okay. Yep. Go ahead and see the timing. Then again fetching the resource. Go to next, call file write, closing the handle. Now, okay, sleep function is there. Okay, to sometimes, yeah, it's needed to finish previous executions, or yeah, sometimes they use to and for anti-analysis as well to evade the debuggers. That we'll discuss later on. And yeah, next, if we say it's running. Okay, we are inside the kernel land again. Okay, Okay, step over those instructions, and if we see, there is nothing happened till now. Okay. uh, okay, winget, this folder is empty. Okay. Let's see, let's dig more. hmm I'll sort it with date modified. Yes. And okay, now you see there are so many files, so you can go ahead and you can just analyze those files. Okay. You will, okay, I'll give you one task, okay, after this, because it's going very long. Okay, once we are done analyzing all these things, there will be a task for you guys. Okay, we haven't collected any network logs over here. Okay, go to sysinternal tool. Okay, check what tool you use to see and analyze network activities, or if you have your own like Wireshark in your mind, okay, you can use that. And then, okay, go and find, if possible, if there is, see which server is trying to connect. Okay, once attack is is done. Okay, you can just comment your answers. Okay, so that will be probably a kill switch. Okay, that needs to be blocked. Okay, so this is it, and there are so many handles going on and on while drop is happening. So many operations are there. So I think all of you guys got a basic idea, like how you can analyze malware or ransomwares. Okay. And this is just a surface. Okay, and you have to dig down. Okay, how he works. Okay, what is the format it follows. Okay, and about pe file structure, all of that you have to know. Only then I think you can go ahead and tell, okay, now you can do the malware analysis. So first you have to clear some of the basic knowledge, okay, that I'm telling you. Then you go ahead and do this. Okay. Yeah, and you keep going on. Okay, so I'm saying, like, okay, is there anything else? Okay, we need to check. Okay, if we are missing anything, so let's detonate it properly. Okay, till last. And I can see there is a lot of crypt file which are WinCrypt file, which are dropped over temp. Okay, now, yeah, I can also see some ATMB files. Okay, I think it's trying to exfiltrate. It will exfiltrate those data. Okay, because I was seeing some OneDrive. Okay, it's trying to access the OneDrive. Maybe that will be the case. Okay, so, what they does is, like, they exfiltrate your credentials. Okay, as well from browsers, because they are saved in some database file, and from that they can fetch all your credentials of various accounts. So, and in OneDrive maybe you have some office related information. They are trying to exfiltrate that information, just to tell you, okay, they also have your data. Okay, these are the password or something like that, to threaten you more. So yeah, it's just to make an impact. Okay, that will be the, like, the end game. Okay, what's the end game here? So they are going to exfiltrate all your data, or encrypt all your data, and if you don't pay the ransom. But if you know, like, how to uh, how data prevention system works. Okay, you just follow that structure. That will save a lot of money, okay, for you guys. Data backups are also a very important part, okay, so I recommend everyone. So I'm seeing these HTML files. So yeah, I think they are related to Microsoft Edge only, okay, so no problem with that. Okay, OneDrive, yeah, as I told you, definitely they will have some information about your OneDrive. And there's a warning, some warning is going on. Okay, this is a image, let's open it. What kind of warning it is? Okay, simple, no problem. Let it be. I will make it larger to see what's happening. Okay, there are just general image icons and all. Okay, so you know right now what it is trying to do. Okay, it encrypted all these, browser information, OneDrive information. Now they'll try to exfiltrate it. Now, they'll have more leverage to, from their side. So this is like just as psyops, going on. They have to break, they are thinking they're gonna break you mentally. Okay, but if you follow proper cyber security, proper blue teaming, definitely they can't get you. So yeah, now we can see, now it's trying to execute WannaCry crypt. That I think this file was present inside your, it dropped file, inside the main directory. Okay, so yeah, it gave me message, but still my files are not encrypted. Okay, and I can just, see what behavior it is doing. So get ID, you can see, okay, free space, okay, get user ID, and lot of operation and that could be performed after this. So they changed my wallpaper and all. So so if you go step by step, and go inside every single instruction, step into those instruction, you will see where they are setting up the wallpaper, where this dialog box is popping from. Okay, because we saw so many times it's trying to fetch the resource section, and trying to execute something. So yeah, now it want to make changes, but there is no UAC bypass for this, so it's not able to do that. So yeah, and you can see wanna decrypt is there now. Task HVC is there. So I think it contains the kill switch. Yep, that file. So yeah, you can analyze the network logs, and you can drop your answer. So if you take this file in resource hacker, you will see, okay, Bitcoin, okay, this lock is there, okay, Bitcoin. mm, and this is the dialog box, they are show popping up. Okay, yeah, and there is timer, everything. So all the controls, okay, this is the dialog box. So I know this is the file where which is responsible to open this. Okay, so yeah, no problem. Okay, so this is it, I'll tell you. Okay, now it's connecting to server. Okay, I think I gave you the answer. Okay, so I don't know it's the answer or not right now. Okay, but yeah, I can see there is a network activity over there. So could be both, it can, this information can be both for attackers, as well as maybe some blockchain wallet address, something like anything can happen, but you have to sort it by yourself. Okay, this is fun task for you guys, because a lot of folks have been asking me, DM me, so what, how we can start reverse engineering, and what to do, and how it looks like. So this is just 1% surface of I think 1% surface of malware analysis. Okay, if you deeper, you will find config parsers are there, and so many interesting stuff. Okay, and sometimes there are 10 level of decryption happening inside the payload, and then you are getting the actual payload and how to decrypt those. There are packers, there are decryptors or cryptors. You have to deal with a lot of stuff in malware analysis. You have to deal with so many different techniques: process hooking, process injection, APC bombing, uh, uh, process and process doppelganging. Yeah, so etc. I can tell you, but yeah, you need to learn after this. So to wrap up today, we explored how WannaCry ransomware works and how to analyze it using static, dynamic, and behavior. And these basic techniques help us to understand how malware operates actually and how to defend against it. Okay, by creating simple rules against that behavior, or about those fragments files, for those indicator of compromise. Remember, even with simple tool and careful observation, it can reveal a lot. Okay, you don't have to be going through so many fancy tools. Okay, if you have a simple tool set, that is much more better. Okay, keep practicing, stay curious, and don't be afraid to dive deeper. Okay, thanks for joining, and I hope this give you a strong starting point in your malware analysis journey. Okay, see ya guys, ciao.